Okay, so on the bottom of your notes on 7.3, did we go over what a hydrate is?
No.
Okay, so it's pretty easy, but I just want to talk through it just a little bit, okay? A hydrate, you probably hear the word kind of hydration, maybe is what it would remind you of. It's talking about water, okay? So last chapter, you made an ionic crystal structure out of candy. It was a lattice. Do you remember what I'm talking about? Okay, so a hydrate is water that can exist in the crystal. Do you remember how you had those open spaces between your candy? Okay, water, a molecule of water, can actually fit in those spaces, okay? So by definition, if you look at the bottom of that page, a hydrate is water that is loosely attached to a crystal structure. And when you hear crystal structure, I'm wanting you to think of that one that you made out of candy, okay, the ionic crystal structure, and we call that a hydrate. So for example, if you were to stay in AP chemistry, I know you'd want to do that. See, Matt, you don't want to graduate, you want to stay with me in AP chemistry, right?
Yeah.
You can determine how much water is attached to a crystal. Water, let's think. How could we get rid of water from a crystal? What do you think? Evaporation. And that might take a while. Sometimes we're in a hurry. So what could we do? Heat it. If we heat water, yes, it's going to go to a gas and it would leave the crystal, if you would. Okay, so for this chapter, what you need to know is what is a hydrate? Okay, it is loosely attached to a crystal. Okay, why you need to know is you're going to be given or asked to find what percent of this is water. Okay, not hard. Okay, to find percents, we still do the exact same thing. Part divided by whole times 100. Okay, so I want you to at least see one example here of how that's going to look. Let's see. How are we doing on percent comps? Are y'all doing okay? Any questions about them? Percent composition. Okay, so I'm going to turn this light off and just kind of talk through this. Okay, so okay, to find the percent composition, okay, of water in calcium chloride, this is, we call it dihydrate, okay? This is the formula for calcium chloride. I know it's ionic because?
Because there's a
Metal and a non-metal, so I know it's going to be a crystal lattice structure. Where did this 2 come from, just as a review? There is 2 chlorines. Why do we need that? Because calcium's a +2 because it's still in group 2. Chlorine's a -1, okay? The dot is not multiplying. It's just representing that water is loosely attached. There are 2 waters. Therefore, we're using the prefix di, meaning 2 hydrates. Pretty easy stuff, okay? It's asking you per this how much percent of this would be water, okay? You're going to take the part, that is water. You're going to divide it by the whole thing, just like what we've done before, times 100. Okay, so let's just be sure we're good. What does 1 water weigh? What'd you guess?
18.
About 18.02, okay? Because oxygen is 16, each hydrogen is about 1.01, okay? We have 2 of them, therefore that's where we get the 36.04 grams. That is the part that is water, okay? We're dividing it by the whole. That's the whole, everything, okay? Multiplying it times 100, and that's the percent that is water. So it's pretty much what you've already been doing. I just want you to see an example with a hydrate. Do you have a question? We're good? Speak now? Okay. Go on in your notes to 7.4. And did y'all get the opportunity to watch the YouTube video? I mean, did you get the link? She gave it to you, right?
we didn't.
But we didn't watch it.
Okay, but you all have computers at your house, yes? Okay, you all just had a snow day. So let me ask one more time. If you're struggling with this concept, did you watch the video? Okay. So I'm about to go over it. And so if you are struggling and think, hey, I still don't know what she's talking about, what could you do?
Watch the video.
Watch the video again, okay, and or for the first time, I guess, and let it help you. Again, not a concept that we're the only people learning it, right? Kids everywhere in chemistry classes are learning about empirical formulas. Okay, two types of formulas: empirical and molecular. Okay, first one I'm going to talk about is empirical. It's the last page of your notes on the top. Okay, the empirical formula is the smallest whole number ratio of atoms in a compound. Okay, what that means is these subscripts will always be reduced and be in the smallest whole number ratio. So if you're given a molecular formula and asked to find the empirical formula, it's really simple. You're just going to look at the subscripts and say, can I reduce them? If I can, that would be the empirical formula. Okay, what type, now you have to think a second. What type of compounds would always be in an empirical formula? So we've talked about ionic compounds. We've talked about molecules. Which one of those would always be in an empirical formula? Thoughts? Okay, so stop and think. Ionic, guys. We take the charges. We crisscross them, and then what do we do with those numbers? We reduce them, okay? That, by definition, is an empirical formula. Their ratios are always reduced. So let me just say that one more time, and you might want to add this to your notes, okay? An ionic compound's formula is always empirical. Its ratios are always reduced, okay? So one more time. Ionic compounds formula is always empirical because we take those charges, we crisscross them, and we already reduce them right there, okay? Now a molecule may or may not be empirical. We have to look at it, okay? So, but I hopefully just made your life a lot easier because you say ionic, hey, I know what that is, okay? I know it's going to be empirical. Questions on that? Okay, so how are we going to figure out how to do one? Okay, you've got the steps. There's actually 3 steps, and so it's not like it's really complicated. Okay, you're going to find the mass of each element. You may highlight, treat percents as grams. So what does that mean?
It means like if it's 34.2%, just put 34.2 grams.
Yeah, literally you're just changing the units. You're taking the percent off and you're putting grams on there. If you're already given grams, yay, okay? You are already in mass. You don't have to even change this unit, okay? So step 1, treat percents as grams, okay? Step 2, you're going to find moles of each element. How do we do that again? Divide by the what? The molar mass, red number on the periodic table, just like from chapter 3, we're converting grams to moles, okay? Then you want to divide moles by the smallest number to find the ratios or to find the subscripts, okay? You look at your mole amounts, you literally find the smallest one and you divide by that one, just like you would in math class to put it in a ratio form, okay? When necessary, you may need to multiply subscripts by 2, a 3, or a 4 to get whole numbers. We're not going to have a 1.5 as a subscript. They're going to have to be whole numbers, okay? So let's kind of go through a problem and see what this is going to look like. Find the empirical formula for a sample of 25.9% nitrogen and 74.1% oxygen. By your notes, what is our first step? No, very first step. Percents go to grams, so that's easy, okay? We're just changing the units. What does step 2 on your notes say? Divide, yes. Converting to moles, this number is found on the periodic table. Okay, so we're getting this amount of moles of nitrogen. We're doing the exact same thing for the oxygen. Okay, everybody good where the 16 comes from? Red number, periodic table, okay? This time we get 4.63 moles of oxygen. Okay, now what is my third step? divide by the smallest, and I can see that 1.5 is 1.85 is a smaller number than 4.63. That's why I'm dividing by that one. Okay, the smallest number is what we're dividing by. Let me tell you what most students do is they get to moles and they stop. They forget to divide by the smallest one to get the ratio. Okay, if there's a step you're going to forget, it's going to be that one. Okay, divide by the smallest, so I'm getting 1 mole, obviously, of nitrogen and about 2.5 moles of oxygen. Is that okay?
Times 2. So
I need some whole numbers here.
2 more
Okay, right. Awesome. Okay, so going on here maybe. Okay, so initially we would say we would have an empirical formula of 1 nitrogen to 2.5 oxygens, and I hear you say that's not okay. We need to multiply by 2. Why? Because we're getting a whole number ratio. Okay, when I do that, I get N2O5. First of all, you should say, hey, that's a molecule. That is covalently bonded because it's 2 nonmetals. And she just told me that ionics will always be empirical. This is not ionic. Would you agree? Okay, so we're trying to figure out what its molecular formula is. Okay, that's where we're going with this. Okay, do you have questions about going from here to here?
I just have one thing. What would you say would be like when you know you need to multiply it? Like if it was like 2.3, like would you still? No.
You do. There is a level of rounding. Is that what you're kind of, I think, referring? And first of all, you need to carry 2 decimal places on molar mass for sure. Okay, and hopefully, if you did some of these or looked at the review, like it'll come out. If it comes out to like 3.999, you know, obviously that's 4. You're good to go. Okay, and we'll look at some. But if it comes out to a 0.5 or a 0.25, what would I do with that one?
2.5 would be
4. Okay, so normally you're going to multiply these by 2 or by 4. Okay, what does that mean? Is you're going to have a 0.5 or a 0.25. Okay,
like,
otherwise you're going to
but
round.
if it's like 0.45, it would still do probably right here, right?
Yes. And we'll look at some more because I know you kind of have to figure that out a little bit. Okay, do you have questions on how to find the empirical formula? Okay, so the second type of formula is a molecular formula. It's covalent. Its formula might be empirical, but we're going to have to check it and see. We're wanting to check to see how it truly exists as a molecule, covalently bonded, okay? So if you have an empirical formula, for example, CH3, it is empirical because I can't reduce a 1 and a 3, okay? But it might actually exist like this as a molecule, and that's what we're going to be checking, okay? So some things that you need to know, it's pretty easy. 2 things. It's on your notes, middle of the page. Is that Roman numeral 2? Somebody, I'm not looking at it. Under molecular formula. Okay, you need to find or be given the empirical formula. Okay? You also need to know what it weighs as a molecule. It will be given to you in the problem. Okay, so how are they going to get you on these questions? What they could do, you have to find the empirical formula first. That's what we just did. Okay, and then they're going to give you the mass as a molecule, and then you're going to check to find out what its molecular formula is. Okay, everybody okay? So that under Roman numeral 2, like highlight that, put a star. 2 things next to it. I have to know the empirical formula, and I have to know what it weighs as a molecule. And again, that number will be given to you in the problem. It's not like a mystery or whatever, okay? So if you're not given the empirical formula, you must find it. That's what we just did. And you can refer to the top of the page if you're wondering, how do I find an empirical formula? That's those 3 steps at the top of the page, okay? You need to find the empirical formula mass. How would I do that? Add them up, look at the red numbers on the periodic table and see what the formula mass weighs, okay? You want to divide the molecular mass by the empirical mass, okay? You're going to multiply each subscript by the answer to step 3, okay? The one that you have in your notes, if you look at the bottom of that last page, I think you have OH, Someone tell me again, I'm not looking at it.
Yeah, it's
HO, so it should show it weighing like 17 as an empirical? Not a molecule. What does it weigh as an empirical formula? 17.01, right? The 34, if you look at your notes, is what it weighs as a molecule. Everybody okay with the numbers and where I'm at? You're going to divide those. That's X on your notes. Some of you are not looking at your notes, so I'm thinking it's going to be really hard for you to know what I'm talking about right now. Okay? So you're taking the molecular formula over the empirical formula mass, you're getting some number X. You're just dividing, okay? You're going to take that number and you're going to multiply it, that's the N, by the empirical formula's subscripts. So let's look at one. This is how they're going to go. Okay, if you want to write this down, great. You're about to do a bunch of them, as much as I can. The empirical formula for ethene is CH2. So that's one thing I need to know. The empirical formula, it just gave it to me, okay? It says find the molecular formula if the molecular mass is 28.1. This 28.1 is what it weighs as a molecule. Okay, it's telling you that. It's in the problem, okay? The empirical mass, I need to find it. It is 14.03. Where does that come from? 1 carbon and 2 hydrogens. I'm adding it up. That's what it weighs, the weight of the empirical formula, okay? I'm taking the molar mass, okay, that's given to me in the problem, because you don't know what it weighs as a molecule. They're going to tell you that in the problem, okay? You're going to divide it by the empirical formula mass, and you're going to get some number. It's like, a good way also to know, is this going to be a number like 2, 3, 4? It's going to be a whole number, is what I'm trying to say, okay? You're going to take this number, you're going to multiply it times the subscripts of the empirical formula, which again was given to me, okay? So 2 times 1 is 2. 2 times 2 is 4. This is the molecular formula. This is how it truly exists as a molecule, okay? C2H4. Okay, questions? How are we doing?
When we divided 28.1 and 14, what did we get? That 2?
The 2, right. Which in your notes, I think I have it marked as an X. X equaling whatever the whole number is, and probably a 2 actually as well.
So we multiplied the molecular one and
The empirical formula subscripts by the number that you find when you divide them. Wonder if the number's 1.
then it just is.
The same thing. Awesome. Okay. If you divide those and they're the same number and you're getting a 1, guess what? The empirical formula is the molecular one formula. 1 times any number is the same thing.
Kind of tell them what you divided.
I think you can. I have some students that don't even have to do this. Like they can see it and they go, oh, that's about 2 times. I'm going to be multiplying it times 2, or that's about 3 times. Okay, so as you do it, it actually gets a lot easier. Okay, I think. You're right. Okay, questions? Guys, that actually finishes chapter 7. Okay, so let me just really quickly say, for your test on Thursday, okay, you've got to know how to name, okay, correctly. That's what 7.1 is for molecular ionic compounds. Acids are not on the test. We didn't go over them. Yeah, obviously they're on the test. 7.2 is not on the test. That's on oxidation numbers. You're not responsible for that for the test, okay? You need to be able, 7.3, to convert between moles and grams and molecules, which is a review.